Welcome to the next tutorial on current electricity. Here I will be discussing the problem number 6 and then problem number 7. Problem number 6. Now let us look into figure 1.11. This is the one, yes. We have to find out what is the resistance between points A and B. Now this looks little bit complicated, but we can try to simplify this, and this is the way to simplify it. We need to find out what is in parallel and what is in series here. Now look at this. Let me show you. Okay, look at this part, this 20, 10 and 20, this part. Okay, this 20, 10 and 20 ohm seems to be in parallel with this 30 ohm resistance. Okay, so this is a parallel and this is in series with the other two 10 ohm resistances. So let me draw it here. This is 20. Let me draw it little bit thicker. Then 10 and then another 20. Okay, then the 30 resistance below, 30 ohm below. So this thing is in parallel, and then I have 10 ohm resistance on the left side of it, and then another 10 ohm resistance on the right side, which is towards the point B. So this is whole circuit is. Now I think it looks very simple. Now this 20, 10 and 20, this these are the points A and B. Now this whole thing is simplified as this diagram, and I think in future for solving this kind of problems you should always try to simplify it in this way, so that you can solve it very easily. So this 10 is this 10, and this whole thing is coming here. This is 20. Okay, now 20, 10 and 20 becomes 50. So 50 and 30 in parallel. Okay, so 20, 10 and 20 in series, which is equivalent to 50, and there is another 30 ohm in parallel. So what is the equivalent of 50 and 30 when they are in parallel? That means 1 by R equal to 1 upon 50 plus 1 upon 30, which is equal to 8 upon 150. Therefore R equal to 150 upon 8, which is coming to 18.7. Yeah, I think it is coming to 18.7 ohm. Okay, so this part equal to this area, which I am circling with a dot. This is equal to 18.7. Now you see it is lot simple. So there is a 10 ohm, then there is 18.7 ohm, and there is another 10 ohm. So this is 10, this is this is 18.7, and then next 10. So what is the net resistance coming from here? And these are the points A and B. So net resistance coming from here is 10 plus 18.7 plus 10. Therefore net resistance between points A and B is 38.7, which is equal to 38.7 ohm. So resistance between A and B is 38.7 ohm. So let me write it here. Let us see what now let us try to solve the next problem, problem number 7. What is the smallest and largest resistance that can be obtained with 100 resistors each having a value of 1 ohm? It's very simple actually. We know that smallest resistance comes when they are all parallel, and largest resistance comes when they are in all series. that means 100 resistances of 1 ohm each. So smallest resistance possible when they are all connected in parallel, and the formula to get the net resistance is value of a single resistance divided by number of resistances. So value of a single resistance will be, so smallest when all are in parallel, and the net resistance will be value of a single resistance, that is 1 ohm, divided by total number of resistances, which is 100. So will be 1 upon 100, that means 0.01 ohm. Now what will be the largest resistance? That means when they are all in series, 1 ohm, 1 ohm, 1 ohm, all the way up to 100, they are holding hand to hand, and then the net resistance will be 1 plus 1 plus up to 100, which is equal to 100. So when they are all in series, the net resistance will be 100 ohm.